Hi, I'm Phil Lesner, YAGEO CTO, and I'd like to talk to you today about artificial intelligence, or AI, and its impact on YAGEO. Artificial intelligence is a hot topic these days, and with the release of large language models like ChatGPT, we believe the era of AI 2.0 is upon us. Today, we'll explore what AI is and how it is relevant to YAGEO's current and future products. So the outline for today's webinar is we'll cover what is AI, why now, AI challenges, and YAGEO's role in meeting those challenges. I'd like to start out with a quote by Google CEO who said a few months ago, artificial intelligence is one of the most profound things we're working on as humanity. It's more profound than fire or electricity. Now, you may agree or disagree with this quote, but I think everybody will agree that AI is having an impact on our lives and our work. So let's look at first what artificial intelligence is. So artificial intelligence is defined as a simulation of intelligent behavior on machines, and it's actually been around, or the concept of AI has been around for quite a while. Since the 1940s or 1950s, when it was really defined. We generally deal with a subset of AI called machine learning, and that's a type of artificial intelligence that provides computers with the ability to learn a model from data and generalize that learning to new data. So in classical programming, the programmer starts with a predefined set of steps and predefined procedure and runs the data through it and gets some type of output. With AI, the program or the model actually learns from data and then learns to predict new data. So one of the oldest applications of machine learning is actually spam detection in your email. So in spam detection, the model is trained on spam and not spam email, and that's called the training phase. And then new data or new emails are shown to the program, and they predict whether these emails are spam or not spam. Some of the newest techniques in machine learning are called deep learning or neural networks, and that's primarily what we'll focus on because those are the types of machine learning that are being applied to the most advanced problems today. So let's look at why now. So really, as I said, it really starts with the algorithm or method or model for the machine learning. And actually, the basis behind deep learning or neural networks was invented or conceived in the 1940s when the artificial neuron was conceived. But it was many years until they figured out how to actually train the models based on these artificial neurons, and that didn't happen until 1986, when Professor Hinton at the University of Toronto invented a technique called backpropagation, which allowed for the efficient training of neural networks. It was another few years until the late 1980s where the neural networks that we use today for a lot of the applications were invented. Those are called convolutional neural networks, or CNNs, and recurrent neural networks, or RNNs. But it was actually many years later, over 20 years later, before these CNNs and RNNs were applied to image recognition and voice recognition. So those applications really came into the fore in 2012. I've shown some of the popular consumer-facing ones here, like Amazon Alexa and Apple Siri for voice recognition, and Google Lens, and another application for looking at identifying plants for image recognition. But of course, there are many, many more of these. And in fact, some of these techniques like image recognition are actually used also industrially, like in YAGEO factories for optical inspection. Natural language processing lagged behind image recognition and voice recognition. That really depended on the invention of something called word vectors, which was invented at Google in 2013. And then several years later, this was applied to Google Translate, so the area of machine translation, which greatly improved the quality of translations between languages. More recently, another deep learning technique was invented. It's called transformers, and that was invented in 2017, and that led to these large language models that were released last year. So the most famous one of those that probably everybody knows about is ChatGPT. Google has its own version of it called Bard, and then there's another one that's popular called Claude by another company. So we need to ask ourselves if basically the techniques and mathematics behind these neural networks were discovered in the 1980s. Why did it take over 20 years for actually applications to become available that took advantage of these algorithms? And the answer is really in two parts. The first part of the answer is compute. So you need a lot of computing power in order to solve these neural networks. They have many parameters. It's very computationally intensive. Of course, automatic computing goes back to the early 20th century, where first mechanical computing devices were used. So shown here is the Hollerith tabulator used in the early census era. And then in the 1940s, electronic computers were invented. The first ones were based on relays and vacuum tubes, and then later in the 1960s on transistors. And you could see computing power, steadily increasing, and this is a logarithmic scale, so it's really exponentially increasing, starting really in the 1940s with the invention of the electronic computer. The microprocessor CPU was developed in the late 1970s and early 1980s. I'm showing the Intel Pentium here, but of course there's many others. And that really not only increased the accessibility of computing, but really the computing power that could be applied to a problem. But still, even with the microprocessor and its bigger cousins that were used in back-end servers, there was still not enough computing power for these neural networks to be computed efficiently and in a timely manner, and serving up the results to the end customer in a timely manner. It wasn't really until the early 2000s that the GPU, or graphical processing unit, was first applied to these problems. These units were first used for gaming, but it turned out the type of parallel processing that are used for gaming graphics are also very applicable to artificial intelligence and machine learning with neural network problems. So I call that the transition to heterogeneous computation, because today in modern AI systems, both GPUs and CPUs are used to solve these very computationally intensive problems. You can see that with the invention of heterogeneous compute and GPU, the exponential growth of computing power continued, and that's sometimes called Moore's law. So the other ingredient that you need for neural networks and deep learning is lots and lots of data. And the reason we need lots and lots of data is because these networks have many, many parameters. So you need many data points in order to properly fit these parameters. So this graph here shows the number of parameters versus time, and you can see that from this graph, there's about a 10 times increase in the number of parameters per year. now with the latest models that are being applied for these large language models like ChatGPT. There actually are billions of parameters used, and maybe soon for some of the cutting edge models, there'll be trillions of parameters. So where do you get all this data? Well, that really happened with the explosion of the internet. For the first time, there were billions and billions of documents available, or images or sound bites available that from videos or podcasts that these deep learning algorithms could be trained on. So this graph shows the explosion of data over the last 15 to 20 years or so, and you can see that most of the data that's become available is what's called unstructured data, which is things like images and documents on the internet, as opposed to structured data, which is data in more traditional databases. And I like to show this quote from Peter Norvig, who's the Senior VP of Research at Google. He said about Google, we don't have better algorithms, we just have more data. And that's to a large extent true. That's why Google is one of the leaders in the artificial intelligence and machine learning space, because they have so much data that they've been able to collect through their business model. So let's switch to talk about some of the issues with artificial intelligence and machine learning. So one of the biggest issues is really power. So the human brain is a quite efficient organ. It uses about 20 watts of power to do all that processing. And of course, humans are capable of, recognizing images and sounds and understanding documents and giving answers. On the other hand, the state of machine learning today and deep learning in the cloud, they basically need megawatts of power in order to perform the functions that we're asking them to do. So, that's a lot of power. And in fact, energy from data centers uses about 3% of the energy from the global power grid. So that's a significant amount of energy. Now, of course, not all that energy and power is going into artificial intelligence applications. There's many other applications that are going on inside data centers, but artificial intelligence is taking a growing share of those that power. And in fact, software like ChatGPT has accelerated the amount of power used. Typical cloud server might use 300 watts of power, but an AI server could use over 1,000 watts. So that's 3 or more times the power that a typical data center server uses. A single AI training run can consume about the energy of 120 households in a year. So that's a lot of energy. So you can see that even a 1% saving in energy that's used by AI would be a significant energy savings, and having to delay, the building of new power plants and infrastructure. So how does YAGEO fit into this? So one way we fit into it is by actually helping the data center operators save this energy. So that's in energy savings. But the other point I want to make here is that because there's so much energy used and because of the inefficiencies, these components run really hot. So it's not only energy savings that lower loss components will help with, but also help managing the heat in servers. So listed an example of some of the components that we're working on that are aimed toward AI applications. This is not, of course, a comprehensive list, but just an example of a few of the components that some of the PBUs are working on. So one is nanomet inductors. So this is a new type of inductor material that allows much lower losses and higher currents than conventional inductors, and also allows some miniaturization so they could fit in a more confined space. The second thing is low loss Class 1 MLCCs, U2J and C0G dielectrics, and in fact, these have already been applied to some applications in servers. And then the third is low ESR tantalum polymer. So tantalum capacitors are used where high reliability is needed and constrained space. ESR, equivalent series resistance, and the lower the ESR, the lower the loss of the component. So there's a lot of effort and demand from customers to pushing these tantalum polymer capacitors to lower ESR. Second area that we're working on is higher voltage. So traditionally, the power has come into the data center and then been converted to 12 volts, where it's distributed then to the various systems, and then the voltage is stepped down from there to supply the voltage to the core CPUs or GPUs. There's been a trend to go from 12 volts to 48 volts. So by raising the voltage, you can lower the current and therefore lower the losses in the wiring. So 48 volt systems need higher voltage components. So our customers are asking us for 50 volts, 63 volts, and 75 volt components in order to power these systems. And we've obliged with that and already been designed into some of these advanced power distribution systems. Another area of work is higher reliability components. So if you can imagine that to train these models with billions or trillions of parameters takes time. Training runs could take days or maybe even in some situations weeks. So the failure of a server during the training run would be actually very bad, catastrophic, because you might have to start over, and that's a tremendous cost. In fact, some of these training runs, the cost of training the model could be in the hundreds of thousands or even millions of dollars. So if you had to start over, it could mean a significant economic penalty, and therefore customers want components that are guaranteed to have high reliability, so they have a very low probability of failure during operation. And then the last area I'll mention here is compatibility with immersion cooling. As I mentioned, these components get very hot during the run because of the high power of these servers. Traditionally, air is used to cool the server, but that with these high power servers, that doesn't always result in enough cooling to keep the components cool enough. So there's a move toward immersing the components and cooling them with a liquid instead of using air, which brings a whole host of questions around compatibility of these components. So we're working with the major server manufacturers to understand the compatibility of our components and potentially develop modified solutions for those components that have issues. So I just like to finish by mentioning that YAGEO has already been successful in designing in components into these AI applications. I've listed, shown here some major customers, Google and NVIDIA, both leaders in the space of artificial intelligence and machine learning, from the end applications and from the basic components. So, of course, Google has the end applications, they have the cloud infrastructure, they have some of their own custom processors. NVIDIA makes the graphic processing units, which are now in extremely high demand for these large language models. We're on several different builds for both of these companies. So I'm looking forward to the future where YAGEO continues our momentum of development of advanced components and continues to get designed in at these customers and the other customers that are emerging in this space. So I thank you for your attention. Again, I'm Phil Lesner. I can be contacted via email or via my mobile phone at these email addresses and phone numbers. Thank you. That's it.